Good morning and welcome to AP Statistics for Tuesday, May the 5th, Cinco de Mayo. Today we're going to go over the 2018 FRQs numbers 1 and 2. So prompt number 1 gave you an output, a mini-tab output, and asked you to interpret, what was it? Let's see, the LSRL's y-intercept. So we have the coefficient constant column that tells you what the y-intercept is. So it tells you it's 72.95. The interpretation in context is that when no one is waiting in line and a customer gets to the line, it predicts about 72.95 seconds until that customer is finished with checkout. Pretty basic. Part B asked you about the coefficient of determination, which is r squared, and it was provided to you in the output as 73.33%. So how do we interpret r squared in context? We say that 73.33% of the variability in checkout time is explained by the linear relationship of the number of customers in line when a customer arrives on the checkout time. And part C, what's the outlier? You're supposed to circle the outlier. Well, there's only really one point that stands out from amongst the others, and that's the coordinate 380, give or take. And what it tells you is that when there were 3 customers waiting in line ahead of this particular customer, it only took 80 seconds for that customer to get all the way through the line and finish with checkout, which is very, very fast according to the remainder of the data points on our checkout grid, as well as any kind of logic. 1 minute and 20 seconds is a very fast checkout with 3 people waiting in front of you. It had a very high, let's say, high residual value, and you could actually use the information in the LSRL to predict what the predicted time was for 3 customers. Would have been 596.15 seconds. So we were really expecting to wait in line for 10 minutes, 600 seconds, and it turned out to be only 80 seconds. Well, that's the answer. Moving on to number 2. Number 2 gave you information about this environmental science teacher who surveys students about whether or not they recycle their bottles. You were asked in part A to figure out how many people were asked the question, and it didn't give you that information. But it did tell you what the interval was. So we were told that we were 95% confident. The interval spans from 0.584 to 0.816. You guys already know that all of our confidence intervals are centered on a point estimate, and that's equidistant from the boundaries of the interval. So what is the actual point estimate? Well, p hat in this would be the middle of 0.584 and 0.816, and that turns out to be 0.7. So the point estimate is 0.7. Great. From the information we have, we could also find the margin of error, which is just the extreme minus the center. So it's 0.116. So I already know the point estimate, which was 0.7 or 70% of the students surveyed said that they would recycle. And the margin of error is 0.116, an 11.6% margin of error. And it was a 95% confidence interval. Well, 95% confidence for proportions means that there was a critical z-score involved, and it was 1.96. So the margin of error, we know how confidence intervals are formed. P hat plus or minus critical z times the margin of error, which is the square root of p hat q hat over n. The only part of this I don't have is the n. I don't even technically need the p hat plus or minus part because I'm really just going to use the margin of error to find out what the sample size was. So the margin of error, which was 0.116, is equal to critical z-score 1.96 times the square root of p hat 0.3, p hat's 0.7, q hat's 0.3, over the unknown sample size. Are we gathering how this should be done now? So we divide both sides by 1.96. I'm not going to make this a decimal. I'm just going to keep it as a fraction. All right, I'm going to multiply the 0.7 and 0.3 for 0.21. I'm going to square both sides, so we have 0.116 over 1.96 being squared, and that's 0.21 over n. We would multiply by n, then divide by this side. So really, n is equal to 0.21 over 0.116 over 1.96 squared. And that is 59 9 something? Yeah, 59.95. We'll call that 60 people. All right, so with some algebra and the formula for the margin of error, we found out that it was 60 people. Okay. Part B, and the rest of this is much easier. Part B, what's one possible source of bias? The environmental science teacher is asking students whether or not they recycle. So there's obviously going to be response bias. The people that are responding kind of feel a little pressure, perhaps, some self-preservation. They might have just thrown away their plastic bottle, but they don't really want to tell the environmental science teacher they did that. So there's response bias here. It will almost certainly overestimate the proportion of students who actually do recycle, because more people are going to say yes than they should. Part C is ridiculously easy. I would say deceptively easy. If the coin is fair, 50% of the 300 people are required to say no to the question. That's 150 people. That's pretty straightforward. Part D takes a little bit of thought, but not too much. We are forcing 150 people, basically, to say no. The average will say that half of those coin flips will result in a required no response. Okay. So if we find that 213 out of 300 turn out to say no, but we know that we required 150 to do so, we're really looking at the other 150 respondents who were honest. And if you take 150 out of 213, you get 63 who genuinely said no, taking away the people that were forced to, which leaves us with, did I say 63? Okay. What percent is it? So who said yes? Well, if 63 said no, then 87 out of 150, the other guys, said yes. And that's just going to give us our answer, roughly 58%. So we get a point estimate of 58%. So when taking this method, which will remove the response bias, we get probably a more accurate picture of the true population proportion of the students who actually do recycle. Not so much 70%, but closer to 58%. Well, that's it. Now what I'd like you guys to do is please get started on prompts 3 and 4. That's due for tomorrow. Please submit it before 8 a.m. tomorrow. Have a great day.